This video is math quiz number 4. As with all my other math quiz videos, I will be reading the questions and giving you an opportunity to pause and answer them on your own. And then at the end of the video, I will walk through the questions step by step, hopefully arriving at the correct answer. Shouldn't be making these videos if I don't know what I'm talking about. As these are 5 random questions, I'm not going to be giving you the specific formula sheets. I did leave a link in the description to the ABC formula sheet and the state of Florida formula sheet. As always, if your state provides you with a formula sheet, you should figure out which one they use and practice with that version. As for calculators, I recommend you get one of those cheap $2 solar powered calculators that can't do very much and practice using that, because believe it or not, when you take your exam, they're not going to let you use your cell phone and they're not going to let you use one of those scientific calculators because they think you might cheat. So again, get one of these little cheap solar powered calculators and try practicing the math with that. And just a quick note, I do not own any of the questions presented in this video. They were all sourced off the open internet. This is a study guide for educational purposes. If it helps you learn, that's great. Let's get into the questions. Question number 1. A 16-inch pipe is 1,250 feet long. How much 65% HTH is needed to dose it with 50 milligrams per liter of chlorine? A. 6.50 pounds. B. 7.25 pounds. C. 7.96 pounds. Or D. 8.34 pounds. Question number 2. After calibrating a chemical feed pump in your plant, you have determined that its maximum feed rate is 178 milliliters per minute. If this pump ran continuously at this rate, how many gallons would it pump in one full day? A. 10.7 gallons. B. 25.6 gallons. C. 256 gallons. Or D. 67.7 gallons. Question 3. A rectangular tank is 65 feet long, 28 feet wide, and 15 feet deep. How high will the level rise if 67,000 gallons are pumped into the tank? A. 5 feet. B. 12 feet. C. 8 feet. Or D. 11 feet. Question 4. At what rate in gallons per minute must wash water be delivered to a mixed media filter to attain a backwash rate of 15 gallons per minute per square foot if the filter is 20 foot wide and 30 foot long? A. 600 gallons per minute. B. 2,400 gallons per minute. C. 3,000 gallons per minute. Or D. 9,000 gallons per minute. Question 5. A sand filter with dimensions of 12 feet by 15 feet receives 0.75 million gallons per day. What is the hydraulic loading rate in gallons per minute per square foot? A. 2.9 gallons per minute per square foot. B. 29.0 gallons per minute per square foot. C. 4,167 gallons per minute per square foot. Or D. 69.4 gallons per minute per square foot. All right, we're done with the part of the video where I read you math questions. Now we're going to go to the part of the video where I solve the math questions step by step. If you're looking for the answer key, it's not exactly at the end of the video, but it's pretty close. So if you don't want to listen to me blather on, skip ahead. Question 1. A 16-inch pipe is 1,250 feet long. How much 65% HTH is needed to dose it with 50 milligrams per liter of chlorine? Let's start by pulling the known and unknown out of our word problem. So what we know is the length of the pipe is 1,250 feet, the diameter is 16 inches, the percent purity is 65%, and the dose is 50 milligrams per liter. What we don't know is the pounds of chemical we need to use. So here we have the Davidson pie chart, which is pounds per day of chemical feed, 100% purity, divided by the pi wedges of flow MGD times dose milligrams per liter times 8.34 pounds per gallon, we're going to be looking for pounds. So to find the quantity above the horizontal line, we're going to multiply the 3 pi wedges below that line together, and then we're going to divide it by the percent purity as a decimal. So here we have that rewritten. Feed rate pounds per day is equal to the dose milligrams per liter times the flow, million gallons a day, times 8.34 pounds per gallon, divided by the percent purity as a decimal. Now in our case here, flow is going to be volume. So to find volume when given diameter, it's 0.785 times diameter squared times the height. Now your formula sheets always have volume solving for cubic feet, so all of our measurements have to be in feet. So we're going to have to convert our 16-inch diameter to feet. There are 12 inches in a foot. We want this to cancel out, so the inches are going to go on bottom because it's dead to us. It's buried and underneath. So 16 inches times 1 foot over 12 inches. Your inches are going to cancel out. Do your multiplication, and you get 1.33 feet. So now we can plug that into our volume formula. We have 0.785 times the diameter of 1.33 feet squared, so times itself, times the length of 1,250 feet. Do your multiplication, and you get 1,735.7 cubic feet. We must get this into gallons. There are 7.48 gallons per cubic foot, so 1,735.7 cubic feet times 7.48 gallons over a cubic foot. Your cubic foots and feetsies cancel out, and when you do your multiplication, you get 12,983 gallons. Now this needs to be in million gallons for our formula to work, so we're going to convert gallons to million gallons. There are 1 million gallons in an mg, so it's going to go on bottom. So 12,983 gallons times 1 mg over a million gallons, and your gallons will cancel out. This ends up being division. And when you do that division, you get a volume of 0.012983 mg. Now we're going to put everything in our formula. Our dose of 50 milligrams per liter times the volume or flow of 0.012983 mg times 8.34 pounds per gallon divided by the percentage as a decimal, so 0.65. First we'll do the multiplication on the top, so 50 times 0.012983 times 8.34. And you get 5.42. Now we're going to divide that by our percentage as a decimal, so 0.65. And remember, we're going to be getting a bigger number because we have less pure chemical, so it's actually going to take more pounds of it to disinfect. And when you did that division, you should get 8.33 pounds per day, or the closest answer on our question is D, 8.34 pounds. Question 2. After calibrating a chemical feed pump in your plant, you have determined that its maximum feed rate is 178 milliliters per minute. If this pump ran continuously at this rate, how many gallons would it pump in one full day? So we're going to pull our known and our unknowns out of the word problem. What you know is the feed rate is 178 milliliters per minute, and what we don't know is how many gallons that would be per day. So we're going to need to set up a unit conversion. When converting units, remember that whatever you want to cancel out first goes on the bottom. It's dead to us. DED, gone, buried. It is underneath. So we have 178 milliliters over 1 minute. We're going to times that by 1 liter is equal to 1,000 milliliters so that our milliliters cancel out. Now to continue this on, we're going to start flip-flopping like a politician. So our milliliters will have canceled out. Now we're going to get to gallons. There's 1 gallon and 3.785 liters. And like I said, we flip-flop because now we want the liters to cancel. So 1 liter over 1,000 milliliters times 1 gallon over 3.785 liters. Now your liters are going to cancel out. So now we want to get this to days. So we got our minutes to cancel out. So we have 1,440 minutes per day, and that's going to cause your minutes to cancel out. All right, so let's work it from the beginning again. So 178 milliliters per minute times 1 liter over 1,000 milliliters. Your milliliters cancel out. And we're going to multiply that by 1 gallon over 3.785 liters. Our liters cancel out, which now we have minutes and gallons, and we want our minutes to cancel out. So times 1,440 minutes, your minutes cancel out, and you're left with 67.71 gallons per day, or the answer of D. Question 3. A rectangular tank is 65 feet long, 28 feet wide, and 15 feet deep. How high will the level rise if 67,000 gallons are pumped into the tank? So first, pull your known and your unknowns out of your word problem. So what you know is the length is 65 feet, the width is 28 feet, the depth is 15 feet, and you're pumping in 67,000 gallons. What we don't know is how many feet it's going to rise. So first, let's find out how many gallons per foot, and this is going to be a volume problem. So we're going to solve for the volume of the tank, and for a rectangle that is length times width times height. Everything was already in feet, so we can plug it in. So 65 feet times 28 feet times 15 feet. Multiply those together, and you get a volume of 27,300 cubic feet. Now we need this to be in gallons, so we're going to convert. There are 7.48 gallons in a cubic foot. So 27,300 cubic feet times 7.48 gallons over a cubic foot. Your foots and feetsies cancel. So when you do that multiplication, you get a volume of 204,204 gallons. Now we need to find out how many gallons there are per foot of height or depth. So at 15 feet deep, you're going to divide the total gallons of 204,204 gallons by the depth of 15 feet. And when you do that division, that shows you that there are 13,614 gallons per foot of height. So now we can find the rise if we pump in an additional 67,000 gallons. To do that, we want the gallons to cancel out. So you're going to do 67,000 gallons times 1 foot per 13,614 gallons. So it's going to be division, and your gallons will cancel out. And it will rise 4.92 feet. So the answer is A, 5 feet. That's our closest answer. Question 4. At what rate in gallons per minute must wash water be delivered to a mixed media filter to attain a backwash rate of 15 gallons per minute per square foot if the filter is 20 feet wide and 30 feet long? So we're going to pull our known and our unknowns out of our word question. What you know is you want a backwash rate of 15 gallons per minute per square foot. The width is 20 feet and the length is 30 feet. And what we don't know is the gallons per minute pump rate. So the formula to find this is your backwash pumping rate gallons per minute is equal to the backwash rate gallons per minute per square foot times the filter surface area in square feet. So first, let's find the surface area of a square or a rectangle, and that is the area is equal to the length times the width. Everything's already in feet, so we can plug that in. So 30 feet times 20 feet. And that gives us a surface area of 600 square feet. So now we plug our values into our formula. So you had a backwash rate of 15 gallons per minute over a square foot times the surface area of 600 square feet. Your square feet are going to cancel out and leave you with gallons. So 15 times 600. And your answer is 9,000 gallons per minute. Question 5. A sand filter with dimensions of 12 feet by 15 feet receives 0.75 mgd. What is the hydraulic loading rate in gallons per minute per square foot? So pull your known and your unknowns out of your word problem. What you know is the dimensions of 12 by 15 feet, the flow of 0.75 million gallons a day, and what we don't know is the hydraulic loading rate. The formula for hydraulic or surface loading rate, gallons per day per square foot, is equal to the total flow applied, gallons per day, divided by the surface area in square feet. First, let's solve for the area of our square. An area of a square is equal to the length times the width. Everything's already in feet. So we have 12 feet times 15 feet. And we get a surface area of 180 square feet. So we'll go ahead and put that in our formula. But now we need to convert our 0.75 mgd to just gallons per day. So to get 0.75 mg into gallons per day, we're going to do 0.75 mg per day times the 1 million gallons in an mg, and then we're going to times that by 1 day over 1,440 minutes, so everything cancels out. So your mg's cancel out, and your days are going to cancel out, and it's going to leave you with gallons a minute. So do your multiplication, and when you solve your math, you end up with 520.8 gallons a minute. Now we can plug that into our formula for the total flow applied. So 520.8 gallons per minute divided by 180 square feet. And the answer is 2.893, or A, 2.9 gallons per minute per square foot. If you got 4,167, you did not convert it into gallons per minute, and that's why you got that answer. So the answer key for those that were looking for it, question 1 was D, question 2 was D, question 3 was A, question 4 was D, and question 5 was A. All right, so that was 5 random math questions for our little math quiz. I gave you the opportunity to work on them on your own, and then we worked on them together. So hopefully this video helped you practice some math. If it helps you learn, that's great. Thanks.